What if we ain't ready to go live?
I
It's a brand new year, fellas. Brand new year.
What up?
hey,
Wait a minute.
hey.
I
It is a brand
believe
new year. Is this the first? This is the first show for the year, isn't it?
first show of the year.
Man.
Yep.
I should have got an
Absolutely.
energy drink for this one.
It's tough. I know. We gotta spice it up this year, man. We gotta do some different things. We need some ideas. Some brainstorming. We
little
need a
bit of spice.
brainstorming session.
Little Cajun
what I mean?
seasoning on this year.
Mhm.
Mm.
We're all gonna be together, for Brian's event down in Florida. We should ponder what we're gonna bring to the show this year. New ideas. Oh, by the way, if you're new to the show, this is the HVAC Grapevine Show. My name is Chris Hughes, one of your hosts. To my left here, Eric Kaiser. To the bottom, that's Michael Cianfranco. We are scattered around the country, and we try to bring industry news
And other stuff. Random.
and other
stuff.
and random guests.
And random
couple
guests.
couple of dad jokes.
And
a dad
random
joke.
and complete randomness some days.
Yeah. And once I get around to it, a new intro. We need a new intro.
Yeah, we do need a new intro. Both we're all looking kind of young on that intro, and we've gotten old.
Oh yeah.
Time
I've
flies,
gotten-
man. When you're
Except
having
Mike.
fun.
I don't think Mike ages.
Oh, I'm aging, man. All in the belly.
Come on, man.
I gotta get on the bike.
That's
this
why
week.
you don't show that part, right?
That's it. That's it. Right there. That's it.
No, it's because you don't have no pants on.
It's not COVID season.
Man. All right, stay seated.
Yep.
That's your goal for the entire
Got the
show.
suit.
Stay seated.
The tie.
So to kick off the year, I went back to something. I have a feeling we're probably going to talk a little bit about something we've talked about previously, but I'm bringing it up again. Maybe we'll add some more context and content to it. But, if you didn't see the thumbnail, I'm hoping you did. I don't know if you guys did or not. You guys don't pay attention. You just show up, right? Mike's over there. Mike, what are we talking about tonight?
I don't know, man. I just popped on the phone.
See, there you go. You lazy son of a... All right.
Caught me, man.
Unbelievable, man.
Like the teacher.
Unbelievable. All right. So anyway, we're going to talk about trained technicians that exist currently versus equipment with proprietary information. If you see my thumbnail, there's a graph, right? Equipment with proprietary information going up and up and up, which we all know. And then trained technicians, and I had the graph going down. But I really think it's not quite going down. Let's just say it's kind of flatlining. It's rippling, but we're probably not seeing this massive spike, right? This isn't happening, and we know that. So I'd like to talk about that.
Yeah.
Go for it. Let's talk
Absolutely,
about
man.
it.
All
Let's
right.
talk about it.
So, obviously, stating the obvious, there's a bunch of benefits for manufacturers to have proprietary information. Am I right?
Well, I mean, there's some benefits to them to have proprietary information or proprietary control systems, and there's some downsides to it. I think in general, a lot of the proprietary stuff is somewhat proprietary, but a lot of it is also technology that the technicians by and large haven't kept up with, maybe haven't been able to keep up with.
What would you say when you say the technicians haven't kept up with it? Are we talking about keeping up with fundamentals, like getting regrounded on fundamentals or advancing their fundamentals? or we're talking keeping up with proprietary information of all different brands?
Well,
That's a huge topic differentiator there.
okay, so to me, the first thing you said right there is fundamentals, and I have to ask at that point, what do you define as a fundamental?
I would say, understanding of airflow, understanding of the ACA manuals, principles of HVAC, that sort of thing. I'm not going to put proprietary logic information in that category. I would say a good differentiator would be like a BAS system. I don't think someone's with fundamentals is going to a BAS system is not something fundamentally they should be practicing and working on unless they're specializing in BAS controls. It'd be
Well,
good to do it, but it's
okay,
not. I wouldn't call it a fundamental.
but let's back up. What is a BAS system? What at the root, at the root? Now, Chris, I know you and I have done some commercial work. We've done some building automation systems.
So yeah, I was okay.
You know, what at the very root is that BAS system?
A computer?
No. That's high level.
Okay.
What at the very base is that BAS system? What does it do? Simplify it as much as possible.
It's switches.
And
It's
I'm going to go with right there. It's inputs and outputs.
Okay.
All it is inputs and outputs. And the magic of a BAS system is what it does with those inputs and outputs. What kind of decisions does it make? Right? And this is where I think a lot of us forget. We get so caught up in this. There's a big, I just happen to have this sitting here, right? There's a big friggin' fancy board with all kinds of stuff on it, right?
Complex.
It's complex, man. We look at that and we forget that board is nothing but inputs and outputs.
Mm-hmm.
I like the way you put that, because that board I just wanted to rewire around that thing.
Right? And a lot of people get scared when they look at that big complex board sitting in there with all these components on it, and oh my gosh, what does this do? It's nothing but inputs and outputs, right? This board might take the place of something that a whole bunch of mechanical relays and timers and all kinds of stuff that we could maybe replace each one of those components. But I'll be honest with you, after having worked on some larger equipment where like it's literally, a 3 foot by 4 foot panel that's filled with mechanical relays, mechanical timers, and trying to troubleshoot that, because then you have to check the inputs and outputs of each and every single one of those components. And if there's a problem, any one of those components could be bad in there. And you've got to understand that entire logic to be able to go through and troubleshoot that. But this board,
I miss some of those days.
Well, it's a lot of fun. It's challenging. And the first one of those I pulled up, I looked at that and I was like, oh my God, what am I doing? And why am I here? Right. But
I was going to tell a short story.
This board here, right? It's nothing but inputs and outputs. That particular board takes inputs from a thermostat, right? And it outputs to do something. It takes inputs and it makes output. Now, the challenging thing with some of these newer systems is that they're not taking analog inputs, right? Now, or they're not taking an input that we can test and that we can see with, like, say, a voltmeter.
Yeah.
Okay. Yeah.
We can't control that with a jumper lead. Now they're starting to take a digital input, and it's not really I shouldn't say a digital input, because digital is really just on and off versus analog, which is variable.
It's
right?
communication.
They're taking a communication input that is a lot harder to see, and we have to have some way to decode it. And we have no idea of what that's really doing, everything that's going back and forth on that.
That's
And I thought that's what you meant
Yeah.
with the
that's
the
what I'm
title.
getting at with BAS
Well,
systems. Yeah.
Yeah, but still, at its root, my point is that a properly operating BAS system is nothing but inputs and outputs. And that's just like this board. It's nothing but inputs and outputs. And I
Yep.
can test pretty much all of those inputs and outputs. All right, I can
Fair.
test most of that with a meter. And the ones that I can't test as far as inputs, because a lot of your inputs are going to be, if it's a proprietary communicating system, it's going to be that communicating, it's going to be a digital signal coming down there that we don't have the technology to read in the field.
But I hear what you're saying. But then there's the part of a BAS system where you have the computer, the controller, and all of that before you get to the inputs and outputs that are all
Well,
communicating through the computer.
right. And that's all communicating through the computer. But if the computer is programmed correctly and the technician has
Proprietary training on it.
no, all they need to know is what?
Well, I would say a lot of those can almost self-diagnose,
The
I think
technician needs to know sequence of operations.
Yeah.
To me, a fundamental understanding, and a computer is really just a front end. It's just an access point into that BMS or BAS. It's not anything more than just something that we interface with. Okay.
Yep.
It's just a
GUI.
fancy thermostat on the wall that controls a whole bunch more stuff from one location.
Now, don't forget, I'm just a residential guy. What's the BAS normally set up in, like a supermarket, or is it like
so
a
BAS is building automation system.
Mhm.
All right. And it can be set up on an office building. It can be set up
Okay.
on, anything where you want to control, like, so for instance, I've experienced BASs from a really young age. I didn't know a lot about them, but my dad, when I was, I don't know, probably still in single digit age, we'll put it this way. All right. Still in single digit age.
Diapers.
He set up a BAS system. Well, okay, maybe not that young. They didn't have the computers necessary. They set up a BAS system on the college where he worked at it. He was the one that spearheaded the whole project. And I'll put it to you this way. When he started running that system, it ran on 2 5 1/4 inch floppy drives.
Oh, floppy disk.
No hard drives.
Oregon Trail.
Yeah, pretty much. And a green screen, an old IBM green screen monitor.
Wow.
That was the first BAS system that ran this entire college, right? They could control lights. That was really early on when power companies were starting to do different rate structures. So they would, especially in commercial accounts, if anybody knows commercial accounts, they would base your utility rate on your peak demand.
Oh,
so the higher your peak, the higher your total year's utility rate was. And they started looking at this and realized that they could monitor all that. They could watch that peak demand real time, and they could load shed across their campus to be able to control all of this stuff. And they could do things like scheduling on lightings. Well, they had schedules on their lighting panels all the way across the campus, their lighting controls. And if they were going to have an event, now there's manual overrides in every room you have to have with a key. But if somebody has an event, they can call up, schedule it. It automatically turns the lights on ahead of time. They're ready to go. But the most important thing was after the event's done, then they got to turn the lights off and not leave them on. So you know, that was a really early BAS system. But again, it's nothing but inputs and outputs, right? It's an input maybe coming from a computer. So you might have to look at the thermostat and say, what mode am I supposed to be in? Okay, I'm supposed to be in heating mode. What are my outputs supposed to be in that heating mode? Oh, I should have power going to my gas valve. Oh, I should have power going to my compressor. Right? Oh, I don't have power going to my compressor. Well, then that means that there's something lost in this board. If you have an input and you don't have an output, there's something lost in the middle. Well, what's the common denominator? Where is it getting lost? Is it getting lost in here? Is there a safety switch that feeds all back into that board? Okay. It's a little more complex inputs, but it's still inputs and outputs. And that's my point with all that long ramble there, is that it's still inputs and outputs. And that's a fundamental that I think a lot of technicians in the industry miss.
Well, I think it's when you say inputs and outputs, it's easy to say that, like it's easy to understand, but there's different types of inputs and outputs.
Oh, 100%.
Right? So that's where I think the bar gets raised and it starts to get heavy. You know? It's not all 24 volt, switch legs happening. It's different things.
Not always, but it's still inputs and outputs. And in order for us to remember and be willing to dive into some of this stuff, we got to remember it's just inputs and outputs.
I think a good secondary class would be having a class for technicians on all the different sectors of inputs and outputs, right? Like fundamentally understanding.
What are they? Let's rattle some off.
Oh man. Well, you could go DC. You could go DC volt. You could go AC 24 volt. You could do dry contacts, which is, no voltage running through it. You could do.
I mean, okay, so your basic inputs are going to be
a transducer tying back in, sending a variable signal.
Mm-hmm.
I don't know.
Yeah.
Trying to think if there's what else is out there. You could have pneumatics in an old building, converting the signal to something else and then sending that to the board. I've seen plenty of that.
Oh yeah. Your
that's very common.
PE and your EP converters. Those are fun. Those are always fun to figure out.
Yeah.
This one right here is actually one that's coming more into the industry that not a lot of people understand, which is pulse width modulation.
Oh yeah. Yeah.
That's something. And that you've got to have an oscilloscope to be able to see it.
Am I right?
Oscilloscopes.
Is PWM, is that the process where the loops happen in the whole time and there's a constant shift, right? You're monitoring, or am I thinking of something else?
So if you look at it on an oscilloscope, it's a square wave, and they're changing the width of the pulses. It pulses up and pulses back down, and they.
Thank you, John. Sorry, PID loop. That's what I was thinking of.
Yeah, PID loop. But again, a PID loop has inputs and outputs to it, right? It takes information in, and that's part of the programming behind it. That's not, it's going to be part of the sequence of operations ultimately, but it's an internal thing that takes an input because you have to have something to turn a PID loop on, and then it makes an output. That's all.
The hell's a PID loop?
Proportional, integral, and derivative. Now we're going to that's getting
absolutely.
really deep in. That's in the programming side. That's in the setup side and the programming side, right? Now,
I just had to refresh my memory. That's all it was. Yeah.
If it's not set up right, the PID loops may need to be reprogrammed, but that's in something that is something that's programmable. If it's a board like this that's set up from the factory, there's no programming that. That's all set up already.
There's
true,
no loops in that thing.
But think about it. How many technicians you think fundamentally troubleshoot a PID loop or know where to know when a PID loop's failing? I'll be honest. The PWM, I'm not very confident in that one. That's not one the oscilloscope and how you knew how it ranges like that. I haven't dealt with that.
Yeah,
Well,
and it's
the PWM is normal residential communicating equipment, right?
no
No, that's
Oh, that went over my head.
pulse width modulation. It's not used very much in residential. You're going to find it
Okay.
more in commercial. It's starting to become a thing. Now, there is one company out there, Ream uses pulse width modulation for their high-end furnaces as the flame signal. They went away
Okay.
from straight up flame rectification. Now it's pulse width modulation.
I'll
But
tell
that's
you,
on their
last year
modulating.
at the symposium, man, Ream's really stepping their game up.
That's on their modulating and multi-stage gas furnaces. I think anything with a communicating system on it. But
Mhm.
and that's one of those things where they program it in there and they can't even tell you how it works. They program it in. There's an indicator on the control on the wall, and they can't tell you how it works. Now, this comes down to some things like that. Yeah, I think the manufacturers are falling down big time because they're not giving us the information we need to really actually diagnose this stuff in the field with tools.
Are they hiring more tech support guys?
It's turning into just change parts. Hey, change
Just
this, change that.
swappers.
Yeah. Are you seeing this? Change this and change that because that's
Mhm.
what works. So
Mhm.
just change the parts, which
So
it's
just
kind of aggravating to a
bulk it out.
technician who
It's gonna
likes
be
to
right.
train. When you want to figure something
Guys
out,
like
you want to
us.
figure it out.
Yeah.
Yeah.
Well,
Is
and
it
the thing
A,
is,
B, or C?
for many, many years, right? The trade, the top technicians were all like, "Oh, don't be a parts changer. Go in, you got to go in and troubleshoot this stuff." Well, now we're going back the other direction
Don't
because
be a kitty cat,
unfortunately, and here's the thing I learned: some of these manufacturers, when they have these boards, because a lot of the manufacturers don't build their own boards, or they might farm them out to somebody else, especially on the residential side. They may farm them out to somebody else. They don't understand fully how they work. Their in-house people don't even fully understand it because they didn't engineer it.
That's a good point, man. I never thought about that. That's
So
why Eric is the brains.
when they farm that stuff out,
That's a good
then
point.
the manufacturer doesn't understand how it works, and they can't teach us how it does or doesn't work, which is, I find that very, very challenging.
That is weird because even if they wanted to, they probably wouldn't have the means to do it within a couple of months.
Well, it's challenging because on the flip side, how many people out here in the trade don't want to learn something?
Oh, I can make a couple phone calls and confirm that.
We've got, I see we've got 16 people watching right now, right? So if the manufacturers start just, throwing this really high level information out here, who's going to soak it up? What are they going to do with it? And are they going to screw things up worse with that information?
My opinion is it should be out there just so they could point people to it. It would cut down on the tech support. I mean, you could say, hey, the information exists here.
It may actually increase the tech support calls.
I could, I've been in that conversation before.
I've been on the tech support end of that before, and I can say that some of that stuff increases the tech support calls.
I never thought I would hear that comment out of my mouth, but being at TC, we've had conversations, and I've actually said, like that would probably increase tech support if we were actually to like add that feature. And I was like, yeah. So I get it now. But I don't know.
The information should be out there, man. I mean, it should be, just because a cop doesn't know every law, it should be able to be referenced,
Yeah. I mean, I see a lot of different sides of this, and it's really challenging. It's challenging for the manufacturers to strike a balance. It's challenging when the majority of the people that they sell to won't even come into a 2-hour class at a distributor or at someplace like that to learn about new equipment. I mean, it's like pulling teeth sometimes, having been on the distribution side of this. It's like pulling teeth to try to get contractors to come in to learn about something. Oh, I'm just going to keep putting in the same thing I have for the past, whatever years. I'm not changing. I don't want any of that new stuff in there.
I think some PID Loop though. Some PID Loop education is good.
I think a good place to start, and I am of the opinion, right? So don't scold me, but I'm of the opinion that a lot of technicians have never been taught that if you want to check out a sensor, right, you could ohm out that sensor and ohm it out in comparison to the chart. And there's probably a chart in the manual, and you look at it, and and you could do it at 1 temperature, you could do it at 2 temperatures, and see if that sensor's good. I don't think I would say that is a fundamental skill that would be very good to have with the inverter-based systems that are running with a lot of sensors today. And I don't think that skill is very adopted right now in the trade. And I think that would be a great place to start. That needs to be added to the fun. Like if you're in trade school, like that needs to be taught to you. And I don't know if that's happening or not. I mean, I've been out of trade school for like 20 years.
Don't ask Ty about it. He'll let you know how he feels about that situation.
But I mean,
you're absolutely right, because a lot of
problems people are seeing right now is sensors are going bad.
Thermistors. I mean, I had this problem on my refrigerator, right? We bought a new refrigerator a couple years ago, and I had the service company out here twice for it under warranty for bad thermistors. And he had never run into bad thermistors before. This guy coming out doing warranty service on a refrigerator in my kitchen. And
within the 1 year warranty?
It was 2-year warranty, but
2 years?
Yeah.
Okay.
Yeah.
That's a pretty good one.
He was ordering boards and all this other stuff. I'm like, dude, trust me, order those thermistors with it. He didn't.
Yeah.
The manufacturer told him, oh no, those thermistors won't be the problem. It's got to be the board.
Dude, I would have went after the thermistors first. Like it'd been my go-to move.
Isn't that the cheap one?
Same here.
Yeah,
they're like, oh, it's got to be the board problem. So they sent out, all these boards, no thermistors. Guess what the problem was?
God,
I knew a guy.
The 25-cent thermistor,
you know what?
right?
The next round, because they only replaced the ones that had failed. Well, the rest of them, because there's like 3 or 5 thermistors in this refrigerator now, because they got to have all this fancy stuff in there. But so the next round failed. Little old me, I get on the internet and I'm like, I want all the thermistors in the entire refrigerator. Replaced every one of them, and it's working fine now because it was out of warranty, and now it's my problem.
I was just gonna say, man, like what I started to try to do, I didn't do this for like every maintenance contract I ever had, but like especially like sensitive equipment. Like I had a restaurant in the city of New Orleans. They had a large dedicated outdoor air system, and I just bulk ordered all the sensors, and I would just leave extras just packed away in the system. Right? Because they're hard to get just when you need them, and you just have them on hand. And then like every 5 years, we just overhaul it, change all the sensors, be done with it.
There's a couple things I'll say about thermistors, and this right here, thank you, Jason Johnson, right? A decade box can really be your friend. And if you don't know what a decade box is, it's literally just a box with 2 leads, or maybe sometimes 4 leads coming off of it if you have a double decade box. But it's a decade box. It's a single box, 2 leads coming off of it, and dials on the front of it, or switches. And you get to make whatever resistance you want to out of that. So you just move the switches around. You don't have to build them. You can buy them. They're cheap.
That's really crazy, man. I never got into that. That's cool.
So
I thought every decade he would throw a bunch of thermistors in a box.
So all you have to do,
one from the 90s, the 2000s.
There you go.
That's pretty cool.
Yeah. But all you have to do is dial up whatever resistance you want, so you can then attach that to the point where that thermistor was at, and you can say, is this working or not? So you're making your own input to be able to control that input immediately on the site, and saying, and like I said, I mean, you can buy them on
like
Amazon.
A suction line thermistor is like so and so ohms, and you could put it in.
Okay, now so thermistors are typically rated at 25 degrees C or 77 degrees Fahrenheit.
Okay.
So if it says it's a 10K ohm, that means that at 25 C or 77 Fahrenheit, it should be 10,000 ohms.
Okay.
All right. Now, if
What's a
you have
name?
an
What's a name
NTC
brand of a good decade box? I wanted to.
Chris is on Amazon, bro.
I wanted to show a picture of one.
I just
Oh.
bought stock in Decade Box 2
It's
seconds
crazy.
ago.
I haven't heard of that before.
I mean,
They're like hacked.
you know, you can buy them on Amazon. They're not that expensive. If you know, you can get really cheap ones, really fast, fancy ones.
Yeah.
It's funny. Is
Probably
this
for less than
episode is
less than
sponsored by
$100.
Decade Box.
Less than
Oh.
$100, you can pick one up. Brand names, I don't know. I've got a really, really old one that I carry around that's just a ginormous.
Chris, put a link in the description below for YouTube later, and we'll see if we get a couple bucks off each one of these sold.
Yeah, there you go. Brent says IceGo.
IceGo? I just found
IceGo.
one. A Linco. This one looks pretty legit. This one looks like my style. I'm gonna share it.
What you got? Let me see.
Yeah.
So you could use it on a suction line thermistor.
You can use, all you do is you combine it to you build up resistors in there, right? So like
That's what I've seen before. Okay, yeah.
So like if you need, say, you start adding in all these little things, and then this is major, you got major resistances on one side, minor resistances on the other side. That's one's, what I would do is probably.
That's cool.
That is cool.
Because the Kaiser's got it drilled in my head, inputs and outputs, and I'm like, all right, I could supplement this as one of my inputs, and then I could go back to just being half a part changer.
There you go.
Get my guesstimates down to half. It's not always the board, guys. It's not always the board.
It's not always the board. No.
Yep. The funny thing is, the thermistors are so cheap. It's like, why would a manufacturer go to the most expensive thing?
So here's another one, right? So, and this one's kind of neat because you can get different values between those two at the same time. So if you look at, like this is a 10K, this is a 1K, this is 100 ohm, this is 10 ohms between these different pieces here. And then it gives you how many amps, like this will handle 20 MA, this will handle 70 MA. We can do up to 700 MA over here. And what tolerances it is. Plus or minus 1% is a pretty tight tolerance. You can get plus or minus 0.5%. You can go like a 2%.
How many schools do you think have that box?
1%. Wow. That's
better than, I would
way
guess
better than 70%,
Probably very few, honestly, sadly.
That okay. Like I have no dog in this fight, but that seems like that's something that should just exist in every training class. Like, dude, I'm 38 years old, and I'm just seeing this freaking device, and I'm thinking,
crazy.
Man,
and I think Sam pointed out a good piece that I missed. Like, so that is that one may have been a capacitance. So you can get these.
Yeah. I noticed that. Yes, the UF on
you can
there.
get these for like little capacitors and stuff on boards too. It's an electronic troubleshooting tool, but remember, we've got more electronics now, right? We have electronics in HVAC. So yeah.
So
resistance decade box, capacitance decade box.
So if you were a new technician, newer, and you were coming out and you were going to be working on high-end residential equipment, right? We've talked about ohming out the sensors, which I think is huge. But where would you go from there? What would be your next? What do you think fundamentally is the next thing that should be taught to you working on inverter-based style communicating equipment?
Understand the sequence of operations. And I mean, you have to look at what's going to happen first, right? What's going to happen next? What does this respond to in each instance? How does that unit respond to these different inputs?
Let me ask you this question. What do you think about control logic? How many people you think who are now technicians in the field, but let's say a little newer, understand communication, right?
I don't
Maybe
I don't
they
think they
understand.
have to.
Oh, I think you have to. Like
Okay,
if you,
what-
if you,
no,
if,
I don't know,
if you
man.
know,
He might be right.
if you have a weak signal, like let's say I'm not going to name brands, but let's say you have a 3-volt DC signal, and it should be a 6-volt DC signal. That's a problem.
Okay,
You'd have to troubleshoot that.
let me back up. How many times have you run into in your career?
Quite a few. Seriously,
In what
Yes.
situation?
many.
Residential or commercial?
Residentially,
Okay.
Oh,
So
wow.
yeah.
what was the resulting problem that caused that low voltage?
Improper used wires.
Okay, improperly used wire.
Well, I'm assuming. I mean, this is where it gets interesting. Was it the wiring? Maybe, maybe not. Maybe it was something else. But
Well,
single
how did
strand
you-
wiring will tarnish, on the end, and you've only got that one wire carrying the signal. So if you use a
So what was
multi-strand wire,
what was your solution?
what I used to do in a situation like that, if I got a weak signal, I would carry like a spool of communication wire, and if I just open a window to the house, and I would wire it from like the air handler all the way to the condenser and just throw it out the house and tie it in and see if everything worked. And if it did,
Right.
then I knew I was dealing with a wire problem, and then I'd pull new wire.
Well,
That
you
was
know
a
what?
quick way to just kind of.
That's a
it
valid
out.
troubleshooting tool. And I'm going to tell you what, it's a whole lot faster and easier to do what you just described there than it is to get a whole bunch of fancy tools out and test something and try to read all of the communication signals and understand
Yeah.
all that stuff.
Well, it just eliminates it, right? You can say,
Right.
well, that's eliminated. Like I don't have
Right.
to think about a field wiring problem being the problem.
Right.
And because everything's working, then it's like, okay, well now I'm working on internally into the equipment where the problem is.
Yeah.
Right.
So part of this thing with communication wires, and we had the same thing with 24-volt wires, we have maximum wire length. We have wire
Yeah.
length restrictions. We have wire connection restrictions, right? And that's a John Oak's great point right there.
Yeah, I was
You have to
gonna answer that for
understand.
him.
Okay, you
Uh,
got to know. You got to look at the installation manual,
Yeah.
and you got to say, is the right stuff put in?
Yeah. I
Yeah,
just ran into this on that Mitsubishi Multi.
So I would say sometimes yes and sometimes no. Sometimes it was regular thermostat wire, and I would say that was definitely the most common failure I've seen. Something else I noticed, this happened in the city of New Orleans a lot. It just seemed to be like NOLA had a huge problem with that. And what we ended up doing is driving new grounding rods next to the equipment because it's like they just didn't have a good ground. I don't know. But anyway, that seemed to clean things up.
This one right here
Yeah,
is
that's
another
pretty
big problem.
Yeah. Yep. Move those wires away, man.
Okay. You can't run your communication wires and your
High voltage
wires can't run next to each other. They can't be like this. They need to have significant separation. Like normally 18 to 24 inches of separation if you have to run them parallel. Right. Otherwise, they should just cross like this. They should, they can cross.
Wait a minute.
That's why your field piece.
Hold up a second. I got to talk about that. How are you going to do that? Bringing them all into the condensing unit?
Well,
because typically they all tie in close to each other.
They can do it. They can do it for very short distances, right? But you shouldn't be running them for 20 feet or 50 feet or 100 feet across house.
Right. I
get all
understand that
magnetic interference and stuff like that.
You're going to get interference between the two, and that's one of the things that high voltage wiring generates electrical interference. Yes, it gets very noisy, and an oscilloscope can show that on the communications wires.
I almost feel like there needs to be an oscilloscope class offered in the trade for like secondary
maybe
education.
Somebody can come out with a small.
I'm gonna throw a buddy under the bus here, and I know he is busy. He's probably not watching, but harass Roman Baugh about that because he has something started.
Oh, okay.
Yeah.
I know he's I've watched his content where he's shown information about that.
He's
Interesting.
and he
Is
may
that
have
Roman?
time. Yeah.
All right.
If you want an oscilloscope class, Roman Baugh has one started. He shared it with me a while back, and we both talked about it. And it
Spit it out, Eric.
I told him, I said, that's a great class, but it's like a 200 level class, and you got to go back to 100 level before we get into that.
Yeah.
Hmm.
It's like when you're talking to a homeowner about like communication systems.
And I don't know if he's ever gotten a chance to finish the little bit more basic level class, or whatnot to put that on. But he's got a really good class on oscilloscopes, and I know he's got some other stuff. And that dude is super smart when it comes to the communicating systems and really digging in. But honestly, it's an oscilloscope shows you the waveform. So when we talk about AC power, right, we talk about
Mhm.
you have 0 voltage and it goes up and it goes down and it does that so many times per second, 60
Right.
cycles, 60
60
cycles
cycles.
per second.
Per second. Right.
Okay. The oscilloscope visualizes that on the screen, just like a meter shows us the voltage, and it's not not necessarily the average voltage, but it's the nominal voltage that we have in there, because that voltage is actually pulsing up and down when we're talking about AC power.
That's why you feel the jitters when you hold on to that power wire. You know. Now,
Okay.
can you get something on the main circuit line, like your main panel, that could do that? That could change that whole waveform, kind of like a, like can help with dirty power. Because I remember I was getting to a lot of audio like home audio, and they would, some of the power lines, the strips, they would bring it would come in and it would cap it, and then I'm going off the screen here. It would just cap the peak on the on the wave. You ever hear
I
anything
mean,
like a line conditioning device?
It
You could
depends. I
cut
mean,
out
if
frequencies.
that's running it through a filter. Now, you don't want to change the frequency on AC power. You need it to
Oh.
be 60 cycles per second,
Mhm.
because that's what everything runs on.
Right.
Now, you can do things like capacitors on there. There's a number of different things, and it depends on where that dirty power, right? A dirty power is kind of a messed up waveform. It doesn't look right.
That's what they were
It's
saying.
not
Yeah.
nice and smooth up and down. So first, one of the things is you got to figure out where that dirty is coming from.
Yeah.
Where's that
What
noise
makes
coming from
something
on the
dirty?
signal? Yeah,
Electrically.
What makes it dirty? And then what can you do? What can you do about that? Because you need to do, is that dirt coming in from another appliance on the same power line? Is it coming in through the air? Like,
Right.
where's it coming from? So what
How
do you
many
need to do
different
about this?
options are there to make a power line dirty electric?
We're getting really, really deep there.
Yeah,
right
well, I
now.
think it's like turning into the damn SciShow.
And I mean,
Back to ACs.
there's a lot. I'm just going to say there's a lot of different ways. I would hate to even try to guess, because
There's a lot. Okay, all right.
Basically they're
Stick with that.
So like we'll just say yeah, thanks, Brett. I'm not standing here for that long.
No.
I will let's get Brett on here. We're just going to turn this over to him, and he can
You
talk
know,
for the next 2 hours.
I do want to get Brett on this,
man.
this talk, because I know this is Brett's arena, and he's got a lot to offer here.
Before I spend $300 on a line conditioner for my home panel.
Well, okay, so that's a whole different ball game right there, because line conditioner is one thing, but that's also stopping surges,
Okay.
right? Which is a voltage surge, a sudden surge in something, or mitigating those.
Yeah.
So there's all kinds of different things we can have problems with power. Power's not just as like neat as we like to try to make it out.
Brian Orr was recommending that because he does carrier, and they were having problems with boards early on. It was the Was that a line conditioner, that device?
The ICM
ICM.
403.
Yes. Something like that. I think I got it saved on my phone.
Is it 4032? I don't know.
Let's see here.
Well, the 402.
402.
No, 493. Sorry. 493, I think, is for the single phase. Depends on whether you're dealing with single phase or three phase. That gets into a whole different. For residential, ICM 493.
493. Okay.
Yeah. And that is it's single phase surge protection, and it's got a voltage monitor on it, and it's got a contactor in it, so that if something does happen, it just disconnects.
I like that. Yeah, but it doesn't have any line conditioning in it.
That's a different ball game right there.
Okay.
That's a surge protector. That's not.
Yeah, I didn't want to go deep, but then I just want to know if it
because then you're talking about reactive power. You're talking about all kinds of stuff, and that's something we're getting into now more with the variable frequency drives or inverter compressors, or the EC fan motor, the EC motors we're putting on fans. We're getting more reactive power back because we're turning that into a what's the word? We're chopping that AC up into DC, and then we're pulsing the DC to make an AC like signal coming out of it, so that we can vary the speed and the force or the torque of that motor.
Call that fake AC.
All right, I'm gonna switch gears. I'm switching gears. You ready?
Here we go.
Going back to residential talk and how do you think? I'm trying to think how I want to word this question. As equipment manufacturers are going to continue the path of proprietary information, do you think it's in the company's best interest, like mom and pop shops, even the big boys, to stick with a brand or play the field?
Dude, I talked to a big company that does residential AC, and they stopped doing inverter-based systems. They just stepped away.
So here's my take on it. Mike, go ahead. If you got more to say on that, go ahead. Go for it.
I'm just saying, real world, I got a big company in my town, and they were done with it. They're not trained the guys, but I think it's kind of like an oxymoron, though. Like a big company that prides themselves as, top of the crop, top pay, the best installed systems. But they, when a homeowner calls and say, "Hey, I saw this online," or an inverter based system, and they don't sell it. I don't like how do you do that? So that's a little crazy for me. And then you've got smaller businesses that couple van companies to like mid-size. It's tough for them to let their technicians go a day or two, but you got to do it if you're going to do inverter systems. Got to train them.
Yeah, I think any company that is putting themselves out of inverter systems right now is going to be putting themselves in a world of hurt in a few years.
Yeah,
I would say now. I wouldn't even give them a few years.
Yeah, well, I'm going to give them a few years.
I was shocked. I was shocked when I heard that, man.
Yeah,
it's been my experience that most homeowners today, they want an inverter system, and I'm so saturated that I can't see why. But meaning how are they hearing about this? Because I'll be straight up, I don't have cable television, hadn't had it in years. So I don't know are the manufacturers doing a stellar job of marketing straight to the consumer, and the consumers are like, oh man, I got to have an inverter in my house. Like I have come across many homeowners who are like, I want that new inverter system, and I'm like, how do you even know about that?
Well, so I'm gonna step back real quick, and I want to go back to your previous question, Chris. I would play the field, and I would say that they should be playing the field, because locking yourself into one brand, while sometimes it can have benefits,
it's got a lot of benefits, man.
It can have a lot of benefits in certain situations, but it can also be detrimental to you. And I think that the more flexible people are, and realistically, I mean, residential inverter-based systems, They're not that difficult. They are that.
Says the guy with all the knowledge.
They
in
are
that,
in,
Yeah,
in that
Eric,
cranium.
like it's easy for you to say that,
Okay.
man, but it's
Yeah.
They are
dude,
inputs and outputs.
you know a lot, so you can't just say it's not difficult. It
Yeah.
is.
They are inputs and outputs. Once you
Mhm.
understand and you grasp that concept that they're inputs and outputs, a little bit of time with the manual and you can have a good grasp on what that system should be doing.
Yeah.
Okay. Now, I think that maybe a company should specialize in one or two brands. You know, they should pick some brands.
Mhm.
Hey, we specialize in these. We'll work on anything.
Yeah.
And they should be very upfront about that with the customer. And they should say, hey, we specialize in these brands. We will absolutely work on anything. But due to the proprietary nature of some of these, it may cost you a little bit more, maybe a little bit extra for us to work on that, because we're going to have to sit down and learn that. And sooner or later, they're going to learn enough about these brands, because it's just like anything. I used to be able to walk up to just about any Honeywell thermostat and know how to get into that thermostat.
Mhm,
Why?
mhm.
Because I worked on enough of them that I understood it. I could walk in there
Yeah.
and I memorized it. Well,
And listen, I'll say it again. I'm not a Ream guy. I rarely work on their high-end stuff. All I did was took one class with at the symposium. It blew my mind. They're claiming that they're going to open up like a Bluetooth. If you're a dealer or not, you could work on their systems. That's huge. And that was, geez, man, that's what was 11 months ago. We got symposium in a month.
I mean,
That's pretty cool, man.
We got old man Ty over here. You know, he's working with them analog gauges and that R12 and that halide leak detector.
Wow.
Thanks, Ty. We love you, brother.
I spent many hours in attics running like a 150-foot extension cord with my halide detector and never really knowing if it was working very well or not. You know what I mean?
150-foot extension cord on a halide leak detector?
Well, yeah, you know that if I'm thinking right, the halide leak detector is the one in the black box, got the little red ball.
No.
Okay, that's what I'm thinking of. I can't remember that. I can't remember the name of it, but it's the one that got handed to me when I was 18 years old, and they were like, "This is what you check leaks with."
No, that's the H10.
The
H10. Yeah.
H10. And man, I remember having to run.
That's the good one.
The halide leak detector was a torch with a flame on it.
Oh,
Yeah.
no, sorry. Didn't have that. I had the H10. And I remember.
Only them old guys know about what that halide leak detector is. Ain't that right, Ty?
I remember having to get in commercial buildings, dude, and stretch out an extension cord like forever long into the attic, cross the attic, worst spots ever, just to run the H10. And I'm over there. If you've had an H10, then you know this story, or you've been in this situation. You hear the doot, 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 and you're like not even close to anything, and you're like, "What the hell?" Like there's like the refrigerator.
That's because you're breathing on it, bro. You got refrigerant in your lungs,
you're just
son.
tweaking the knob every so little bit till you get the beeping to just be consistent. And you're like, "All right, we're ready to go." And the whole time you're just dripping sweat everywhere.
So the halide torch was a torch. It was like a propane torch. And then whenever you hit the refrigerant, the flame would turn green.
You get that phosgene flare.
Because you got phosgene's questionable.
I got blood coming down my nose. We must have a leak. Does that smell like mustard gas? We must have a leak.
So does anybody offer? I mean, I know well, I want to back up. Manufacturers are getting pretty intelligent on how to keep you locked to their brand. And the reason I'll say, I don't know how it is in y'all's area, but like Eric, you said, I'd play the field. You could. You also might price yourself out of the marketplace. Like in my area, if you're not playing the field, or if you are playing the field, you're going to pay a massive premium to get your hands on inverter-based equipment if you can get your hands on it anyway.
Yeah, man.
They have done a very good job in my area. I don't know if it's like this around the country, but you almost have to be brand specific and tied to a brand if you're going to do the inverter style systems, or else you're going to really overpay for it.
Possibly.
And then you may not be competitive. And that's what I'm seeing. And
so let me back up then. When you say play the field, you're talking about selling, not repairing.
That's kind of what I meant. Yeah, like if I was a
Okay.
company and I was gonna, sell my inverter based systems, would I sell all the brands, pick and choose what I want, or do I stick with a brand?
Okay. Yeah. So in that, yes, I completely agree. That's where I'm saying specialize in one or two brands.
So you're saying specialize, meaning you would sell a brand that
That's
your
what I
company
sell.
knows well. Gotcha.
That's what I sell. That's what I know well. But I'm not going to be afraid to
Oh,
work on anything.
no, yeah, you got to be able to, work on anything, but
Yeah.
it, and I agree with you. I think it would be smart to try to cycle your team through all the, there's not going to, every brand's typically not going to hit your area. You're going to have like 2 or 3 major brands that are going to dominate the market in your area. I would cycle my whole team through their inverter based training, right? For every brand, all 3 brands that are dominant in the area. That way they can work on all 3.
Yeah.
But they're not all 3 probably going to, sign you up and let you distribute. I mean, maybe they will, maybe they won't, but that probably wouldn't go very well in my area from what I've seen and what I know.
Yeah. I mean, it depends on the distributors, and a lot of distributors will, in the early days of the inverters, they were really trying to lock them down. What I'm seeing now is, or what I had experienced when I was still in the distribution field, was it's starting to get looser in there. If you have a decent relationship with a distributor, at least what we had, if we had a decent relationship with a couple distributors, and they would let us come in for their inverter classes, even though we weren't a dealer for that, because they knew we were going to see them. They knew we were going to work on them,
Yeah.
and we were going to come to them for parts. So it was either let us come into the class, learn what the heck's going on with it, learn how to do something,
Right.
or we're going to be calling up their tech support, blowing up their tech support line every time we have to work on a system.
Totally agree, man.
Because
Right?
they can't, they're there to support that product, right? And it's either let the people in and let them have the knowledge, or
Seems like it would be very lucrative for someone to round up all the education for all the inverter based residential brands and teach a class on all of them at one time.
that'd be
man.
rough.
Think how lucrative that could be, though. Where you
That
don't
would
have
be.
to
that.
imagine if you could, have your whole team taught by a person, and that might be a couple days of class, right? But
Mhm,
all the brands works very much similar.
They are really similar, and in my honestly, with looking at different inverter systems and working with several different ones over my career,
mhm.
it's all just inputs and outputs. The proprietary thing, yeah, some of the components on the board are different, and the interface on the thermostat is different. Or it's really an interface panel at this point. It's not just
I
the
think
thermostat.
I remember a
Let's-
guy when I started as a rookie. He goes, "Don't you call it a thermostat? It's a user interface."
Well,
And
I
that
mean,
stuck with me.
in today's world, that is accurate. Why do we call it a cell phone? Because how often do you use a phone on your cell phone?
Right? Yeah.
I would say
I try to.
Most of the
But
time, everything else works better than the phone does.
but the
Yeah,
voltage,
cell does
there's
suck.
the voltage protocols going back and forth between indoor unit and outdoor unit changes from brand to brand.
But how
And
often do you need to check those voltage protocols?
I think that should be I think it's a valid thing you should know before you start touching a piece of equipment. Like, it's something you should know.
Okay, so that's one piece. But
Yeah, but what I'm
how
saying
how often do you have to check that?
if it's broken, it might be
let's
the
see,
first
for-
thing you're checking.
Because I can
You know?
honestly say that I can count on one hand the number of times that I've had to deal with communication voltages in my career working in residential.
I don't know what.
I could name
Very
a couple of my
lots.
inverters were acting funny. I was always checking DC voltage at the condenser.
Very rarely.
Yeah,
I've
I don't know.
had many of those.
They run a lot of
situations.
thermostat wires through the
So-
ground here.
You're looking at House right there. Okay.
He's a unicorn. Get him off of here. Get him
Now,
out of here.
again,
He's like
now,
you,
this-
Eric. He's like,
this
oh
is-
yeah.
this is that in residential inverters. So I'm going to say that that's a rabbit hole that you can put yourself, from my experience and from having done tech support for
Yeah, but
geographically 3 states.
I'm going to go out on a limb. It's because he's doing good installs. Not everybody does good installs.
Okay, so I was doing tech support.
Not good, great. He's doing house.
I'm doing.
I will tell you this
for 3 states, and I never in 2.5 years of doing tech support for 3 states, I never once had to deal with communication faults.
I will tell you this.
I'm shocked.
There was a brand that I stuck with. They gave me communication problems galore. And then I swapped to another brand and all those problems went away.
Well, I mean,
that's what I'll tell you.
That's
I'm not going to say the brand
problem.
But you asked me why.
Remember Brian Orr had an issue with his communicating equipment. Everybody knows what it is, and he's talked about it very openly.
So
I will say this brand came out publicly with if I remember right, they came out publicly later on saying they did have an issue.
Yeah.
Well, so maybe a lot of my problem stems from that issue, and I remember them.
With train, it always comes down to the wiring. It's like every time, it's the wire. It's damn crap wire under a chase in a 4-inch plumbing chase filled with water. And the suction line and the liquid line are in there. It's flooded.
So what should you be putting in that case for wiring? What should you be putting in?
Oh, anytime I sell an inverter, I'm just throwing new wire.
The point is, you shouldn't be putting regular thermostat wire in that situation.
Oh, in the chase, yeah,
correct. If it's full
that's what they do
water,
in new construction. Yeah,
this is what I'm saying. If that chase is full of water, you need to have direct burial rated wire going in there, and direct burial rated wire is actually full of grease if it's communication wire.
Yeah.
And it's going to keep the water out of it. And it's got a thicker jacket on it.
You should run a new wire on the outside of the house and put it in a nice, clean looking track.
That's what we did. We just ran it up the side of the house. Yeah.
So, I mean, get that out of those flooded chases. That's a terrible. I
asked Jim Bergman. I was like, Berg, what are we going to do about all these suction lines on the, he didn't even address it. He's like, get that out of my face. Because it just shouldn't be done. He's like, he's like a politician. He's like, I'm not even going to answer that. Next question. Next question. Yeah. I'm not going to pick on you no more. Goodbye.
Y'all do some weird stuff, man.
Yeah, it's weird, man. I mean, what about all the inverters that I have that dude, I'm picking up heat from the liquid line. I could feel it, right? So I throw the field piece gauges on. I'm like, I'm picking up heat. I could see it on my suction, and vice versa. It's crazy. It's crazy. But getting back to what you guys are saying, that's got nothing to do with train. That's the bull crap from, I mean, they got to start putting this into the building code here. They got to get rid of chases.
So. All I can say is, man, for the first show of the year, I like this one.